Geometry 1-6, midpoint and distance in the coordinate plane. Please walk through the warm-up quiz in your quiz notebook and just pause this video so that you can answer these questions. Please include question number 4. And for your notes, section 1-6 about midpoint and distance in the coordinate plane. So let's review a coordinate plane. You can see the image of a coordinate plane here. So sketch a quick one out for yourself. We know that the horizontal number line is the x-axis and the vertical number line is the y-axis. So we have 4 quadrants. A coordinate plane is a plane divided into 4 quadrants by a horizontal x and a vertical y axes. So recall what quadrant is quadrant number 1? Yep, the quadrant over here, it's positive x and positive y is 1. Quadrant 2 is just to its left. Quadrant 3 is negative x and negative y values. Quadrant 4 is just underneath the first quadrant. The coordinates of a point are given by our ordered pair x, y. So today we're going to use a couple of methods to locate a midpoint. And a midpoint can be located by using a segment's endpoints. And you hopefully recall this from algebra last spring. We did find the midpoint then, and we did that by finding the average of the x and y coordinates of the endpoints of a segment. So let's see what that looks like. Here we go. In segment AB, we can locate the coordinates of A and the coordinates of B. And I'm sure you recall our midpoint formula, which here it is in larger font. You add the x values and divide by 2. We're just taking an average. You add the y values and divide by 2. It's a simple equation for finding midpoint. So here we have this red segment, and it is, I guess, segment PQ, although I don't see P and Q labeled in the picture. But given that P is at -8, 3, it looks like this lower, further left point is point P, and Q is at -2 and +7 in the y. So we have the values. See if you can find the midpoint. Okay, and be sure you pause the video to give it a try. Now we'll walk through it. So the coordinates, the x coordinates for P and Q are -8 and -2, and when we add those, what do you get? Yeah, -10, and -10 divided by 2 is -5. Simple math. When we add the y coordinates, we get a +10. 3 plus 7 is a +10, and so divide that by 2, and we end up with a +5. So our midpoint is at -5, +5. And so if we were to draw our midpoint in, let me grab a little color here. Let me grab a blue. And we were to go left -5 and in the vertical direction +5, we would have a midpoint just about there, which looks good, doesn't it? Looks good. Let me see if I can get this. A second question that could be asked would be, if you're given a midpoint of a segment, x, y, and you have the coordinates of just one of the endpoints, can you find the second endpoint? So once again, we're going to use our midpoint formula, just taking the average of our x and y values. But basically, we end up placing the value for the known midpoint in the known position, and then we're searching for the unknown coordinates of y. So what does that look like? Let's use the coordinates given to us, and rather than having an unknown midpoint, you can see here we have a known midpoint which would be found if only we could find the unknown coordinates of this endpoint y. Notice that the segment itself is called xy. So here we have the coordinates for the endpoint x, 2, 7. And the midpoint has coordinates of 6, 1, so that's plugged in over here where the midpoint is. And now we need to find the unknown value x and y. So what would we add to 2 and then divide it by 2? The entire sum would give us 6. Well, when we divide something by 2 and end up with 6, that sum must be 12, right? So what are we going to add to 2 to get to 12? You got it. Okay, so let's find the x coordinate. 6 equals 2 plus x over 2, and you can use your inverse operations to multiply both sides by 2 and subtract 2, and you're going to end up with probably what you already have, and that is a value of, where is it? 10. There it is, 10. Okay, and let's walk through this for the y coordinate. If y is 1 in the midpoint, then 7 plus something when divided by 2 gives us 1. So this is what it looks like, right? 7 plus what when divided by 2 gives us 1? Well, we can simply isolate the y by multiplying both sides by 2, which is done here. And then we have a simple equation where we can subtract 7, and the unknown was -5. So the endpoints of our endpoint y, the coordinates of y, are going to be 10, -5. Okay, recall at the end of Algebra 1 we discussed the distance formula. And can you remember what we had been studying just before learning the distance formula? It has to do with triangles. It has to do with right triangles. And I hope you're thinking, when you think right triangles, what is the fancy little theorem that we always comes to mind? And you got it. It's the Pythagorean theorem. So the distance formula is basically a modification of the Pythagorean theorem. So both of those, the distance formula and the Pythagorean theorem, are part of this section 1-6. So we know, see if you can remember the Pythagorean theorem. And hopefully you have said a squared plus b squared equals c squared. Yes. Okay, so if we understand that c is always what part of the triangle? You got it, the hypotenuse. That is typically like the segments that we're trying to find the length of in a given triangle. So, as we were just using the coordinate plane before. So if we took the square root of both sides right now, we could isolate the hypotenuse. And that is what the distance formula does. So let's take a look at what it looks like. The distance between any 2 points in a coordinate plane can be found by, taking the square root of x squared minus, the second point's x minus the first point's endpoint's x squared plus the distance between the y values squared. Okay, so again, we're going to walk through this with the Pythagorean theorem in just a moment. So let's see if we can find the length FG and the length JK and then determine whether they are congruent. So to do that, you could turn these segments, imagine that they are a triangle basically, right? So we can create a right triangle here on our coordinate plane. And so that's what we're doing when we're using the distance formula. We're finding the difference in the x values, this distance, and the difference in the y value, so this distance, and a squared plus b squared equals c squared. So we'll do that for both of these segments. So So let's find the coordinates of each point. So the coordinate of F would be at 1, 2, and the coordinate of G would be at 5, 5, right? The coordinate of J is at negative 4, 0, and the coordinate of K is at negative 1, negative 3. Okay, so we got all these coordinates, and now we can use that information to just substitute into the distance formula. This is something you really want to have down, so make sure you have that memorized, right? So they're going to kind of reveal this side by side. So FG has these coordinates, right? So we're just looking at the x values first. So they're using G minus F, 5 minus 1 squared plus y2 minus y1, so 5 minus 2 squared. And then for JK, once again, they're going from K, negative 1, minus the negative 4 to J, and then negative 3 minus 0 squared. Okay, so go ahead and pause and do the math. And come on back, and we end up with 4 squared plus 3 squared, and 3 squared plus negative 3 squared. Interesting, right? And that gives us, in this case, a square root of 25, which is 5. Again, we're taking the principal root because this is a distance, so of course we wouldn't have a negative distance. And the square root of 18 has a perfect square factor. What is the perfect square factor in 18? 9. So the square root of 9 is 3. Pull that out. And we have a distance of 3 times the square root of 2. So can we say that FG, with a length of 5, is congruent to JK with a length of 3 square root of 2? Nope, they are not congruent. So once again, a quick review of the Pythagorean theorem, and we've already had our quick discussion, so there it is again. Just never forget that C is your hypotenuse. So let's go ahead and use the Pythagorean theorem to find the distance to the nearest tenth of this segment ED. So segment ED, in this case, has been drawn. So without even doing the math, like we were doing with the distance formula, we can actually just count, right? So what is the distance of A here? 1, 2, 3, 4, 5. So we can say, let me grab a, we can say, let's start with A squared plus B squared equals C squared. And so we'll say we have 5 squared plus, let's look at this distance B right here. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'll have 9 squared. Whoops, that's not good. Equals C squared. So let's go ahead and figure this out. 5 squared is, 25, plus 9 squared is 81, equals C squared. And so what is 25 plus 81? We have 100, and you got it, 106, equals our C squared. Whoa, that does not look right. C is being squared. Okay, and so now we'll take the square root of both sides, and you can approximate the value of C squared. Okay, so we're taking the square root to find C, right? So the square root of 106 is just a little bit more than the square root of 100, so probably about 10.1. Very good. Okay, so take this quick lesson quiz, give that a try in your quiz and warm-up book, and then you may get to work on your lesson today. Okay, don't forget to pause this, take the quiz, and then I'm going to advance it to the next slide for your assignment. There you go.